Bismillah ar-Rahman ar-Rahim. Dear cadets, Assalamu alaikum. Our today topic is synthetic division. We will discuss synthetic division for exercise 2.5. So, what is synthetic division? So, instead of long division, sometimes we perform synthetic division to reduce equations of higher degrees. For example, degree 3, degree 4, degree 5, etc. Because degree 2 equation they are quadratic, and we reduce them, we can solve them by three method quadratic for equations. If the equation occurs in more than degree 2, that is 3, 4, 5, etc., then we can reduce them by synthetic division if the divisor is a linear term or the roots are given. Then we divide. Simply the method is the simplest one, and we reduce that equation to quadratic form or linear form. Thus we can find another roots of the equations which are in higher degrees. So let's come to synthetic division. What is the method and what is the process? So for synthetic division, come to question 1, part first. Use synthetic division to find quotient q of x and remainder r of x. By long division, if we divide one polynomial by another or one number by another, so at the end we get remainder. If the remainder is 0, then this means, for example, 4 divided by 2. So we can write 2 to the 4, remainder is 0. Thus 2 is the factor of 4. This is called factor theorem. If remainder is non-zero, for example, we divide 9 by 2. So 2 4s are 8, 1 is the remainder. If remainder is non-zero or other than 0, 1, 2, 3, 4, 5, etc., negative, positive, any number except 0, then that is called remainder theorem, because the remainder is not 0. So the method or the process by which we can reduce any equation of degree higher than 2, that is called synthetic division, and the method is this one. First of all, write the equation in descending or ascending order. If there is any term missing, for example, here in question 3x cubed plus 2x squared minus 6 minus 1, the equation given is in descending order and there is no missing term. For example, x square is missing, so we write for x square the coefficient 0 divided by x plus 3. So if we divide by long division x plus 3, we get the same remainder that is we are getting by synthetic division. So for synthetic division, first of all, write the coefficients of write the equation in descending order or ascending order. So mostly in descending order, then write the coefficients 3, 2, minus 1 and minus 1, that is 3, 2, minus 1, minus 1. Next, divided by x plus 3. So divided, we write x plus 3 is equal to 0, that is x is equal to minus 3. Value of x is become minus 3, or minus 3 is the root of this equation. So we divide by minus 3. So division by minus 3. Now the next step, first step in the synthetic division, write the coefficients of the given equation. Next, drop down the first coefficient, that is 3. Multiply by the divisor minus 3 into 3 minus 9, and adding it to the next coefficient, that is 2 plus minus 9 become minus 7. Again multiply minus 7 by minus 3. Minus 3 multiplied by minus 7 become 21, and adding to the next quotient minus 1. So minus 1 plus 20 become 20. Again 20 multiplied by minus 3. We get minus 60, and adding to the next quotient. So minus 1 minus 60, that is minus 61. So minus 61, the last term, that is remainder. So quotient, the given equation is reduced by one step division. It reduces to 1 degree. That is from degree 3 to degree 2. It becomes a quadratic equation. So the last term, that is remainder, r of x is equal to minus 61, which is the requirement. Use synthetic division to find quotient and remainder. So remainder is minus 61, the last term, and remaining these three terms, that is constant x square. So starting from this one, x square, that is 3x square minus 7x plus 20, that is the quotient. So for checking, if we divide 3x cube plus 2x square minus 6 minus 1 by x plus 3 by long division, we will get the remainder minus 61. In quotient, the answer is 3x square minus 7x plus 20. Now part 3, use synthetic division to find quotient q of x and remainder r of x. So the equation is in degree 4. 2x4 minus 3x square plus 5x minus 7 is divisible by x plus 2. So x plus 2, first of all, we find the value of x. X plus 2 is equal to 0. That means x is equal to minus 2. So we will divide it by minus 2. Next, the first step is write this equation in ascending order or descending order. So in descending order, this equation becomes 2x4, x cube term is missing. So we write for missing term is 0 plus 0x cube minus 3x square plus 5x minus 7. Now write the coefficients of the equation in descending order. Write down 2, 0, minus 3, 5, minus 7. These are the coefficients, and division by x is equal to minus 2. So again the same method, drop down the first or copy the first coefficient 2, multiply with the divisor 2 minus 2 into 2 minus 4, and adding to the next quotient 0 into 0 plus minus 4 become minus 4. Again minus 4 multiply by minus 2, we get 8, adding to the next quotient minus 3 plus 8 plus 5, 5 multiply by minus 2, that is minus 10, adding to the next quotient 5 minus 10 become minus 5, minus 5 multiply by minus 2 become 10, adding to the next quotient minus 7 plus 10 become 3. Thus the last term 3, that is remainder, and the quotient remaining terms constant x square x cube. So starting from this one, the quotient become q of x 2x cube minus 4x square plus 5x minus 5, which is reduced to degree 3. The equation was in degree 4. The given equation, by dividing by one root, it is reduced to degree 3 equation. Similarly, if we divide it by another root, it will reduce to quadratic degree 2. If we divide by another root, then it will reduce to linear term, and at the last to constant term. Next, using synthetic division, question 2. Using synthetic division to find value of k if minus 2 is a 0 of this polynomial. 0 mean minus 2 is a 0, mean minus 2 is a root or solution set of this equation. So solution set mean this is one root, we will divide this expression by minus 2 by synthetic division. So first of all, write this equation in descending order. X cube plus 4x square plus kx plus 8. There is no missing term, so write first step, write the coefficient of this equation, equation of degree 3. So 1, 4, k and 8. Now divide by minus 2. So first, by the same method, drop down 1, multiply it to the divisor, minus 2 into 1 minus 2, adding to the next quotient 4 and minus 2, 2, 2 multiply by minus 2 minus 4, adding to the next quotient, that become k minus 4, k minus 4 multiply by minus 2, it become minus 2k plus 8, adding to the next question. So adding to the next question, that become minus 2k, or the and 8 becomes 16. That is minus 2k plus 16, and the last term is remainder. Therefore remainder is minus 2k plus 16. If since minus 2 is 0 of the given polynomial, so if it is 0 or root of the given equation or solution set of the given equation, then it will be 0 at that value. That is, for example, p of minus 2 is equal to 0, or x plus 2 is a factor, so its remainder is 0. Because if 2 is a factor, it is this minus 2 is a solution set, or minus 2 is the root of this equation, then x plus 2, and x is equal to minus 2, are transforming minus 2 to left side, it become x plus 2. That is, x plus 2 is a factor of the given polynomial. If x plus 2 is a factor, then its remainder should be 0. Therefore we put the last term remainder equal to 0. That is minus 2k plus 16 equal to 0. That is, minus 2k is equal to transforming 16 to right hand side, minus 16, divide both sides by minus 2, minus minus cancel towards the 16, or k is equal to 8. Thus we get the value of 8. So that is the property. If remainder is not 0, then x plus 2 will not be a factor. If remainder is 0, then x plus 2 is a factor. So if given that x is equal to minus 2 is a root, this means x plus 2 is a factor, and if x plus 2 is a factor, then remainder equal to 0. So we put the remainder equal to 0, and thus we will get the value of k. Now come to question 3. Use synthetic division to find the value of p and q, two unknowns. If x plus 1 and x minus 2 are the factors of this polynomial x cube plus 2px square plus qx plus 6. So since first of all write this in descending order, x cube plus px square plus qx plus 6, there is no missing term, no roots. X plus 1 and x minus 2 are factor, so put x plus 1 equal to 0. We get x is equal to minus 1. Similarly, x minus 2 equal to 0, x is equal to 2. Thus minus 1 and 2 are the roots of the given equation. So we divide this one by one, first by minus 1, then by 2. So write down the coefficients of the given equation: 1, p, q and 6. 1, p, q and 6. First divide by minus 1 by first root. So drop down the first quotient, multiply by minus 1, we get minus 1. Adding to the next quotient, that become p minus 1. Again multiply with minus 1, that become minus p plus 1. Adding to the next quotient, that become minus p plus q plus 1. Again multiply by minus 1, that become plus p minus q minus 1. Adding to the next quotient, it becomes p minus q plus 5 equal to 0. Why? Because it is a remainder, and given that minus 1 is a root, or x plus 1 is a factor. So by that property, if x plus 1 is a factor, or minus 1 is a root or solution set, therefore its remainder p minus q plus 5 equal to 0. We get one equation. Second, dividing it by 2. Next, the same continue it. So drop down the 1, multiplied by 2, 2 and the 2. Adding to the next quotient, that become p plus 1 multiplied by 2, that become 2p plus 2. Adding to the next quotient, it become minus p plus 2p, that become plus p plus q, and 1 plus 2 plus 3 equal to 0, because it is the last term, and the last term, that is remainder, since 2 is a root, or x minus 2 is a factor, therefore remainder should be equal to 0. Thus we get two equations. First, since x plus 1 and x minus 2 are the factor of the given polynomial, so the remainder is equal to 0. We get two equations. First equation, p minus q plus 5 is equal to 0. Second equation, p plus q plus 3 equal to 0. Equation 2. Now solving this equation, we get the value of p and q. So by adding 1 and 2, minus q plus q cancel, 2p is equal to 2p plus 5 plus 3, 8 equal to 0. Or 2p is equal to minus 8, divide both sides by 2. P is equal to minus 8 by 2. 2 cancel with 4, 2 for the r, p is equal to minus 4. Now put this value of p is equal to minus 4 in equation 1 or 2, in whichever you can put them. So in first equation, value of p is minus 4, that become minus 4 plus q, in equation 2, p plus q plus 3 equal to 0. So minus 4 plus q plus 3 equal to 0. So that become q minus 4 and plus 3, that become minus 1 equal to 0. Are transforming 1 to right side, q is equal to 1. Thus we get the values of p and q. P is equal to minus 4, q is equal to 1. Next question is 5. One root of the cubic equation x cube minus 7x minus 6 is equal to 0 is 3. Use synthetic division to find the other root. So one root is given, that is 3. We divide this equation by 3 by synthetic division. So first of all, write this equation in descending order. Here x square is missing. So for x square we write x cube plus 0x square minus 7x minus 6 is equal to 0. Now write down the coefficients of this equation of degree 3. So 1, 0, minus 7, minus 6. 1, 0, minus 7, minus 6. Divide by, since one root is given, 3 is the solution set, or 3 is the root, therefore division by 3. So drop down the first coefficient 1, multiplied by 3. 3 1 is 3, and adding to the next quotient. 0 plus 3 become 3. 3 3 is 9, minus 7 plus 9 plus 2. 2 3 is 6, and minus 6 plus 6, 0. So that is the proof. Because 3 is the solution set or root, therefore remainder becomes 0. Last term becomes 0. So the next equation, that is called Depress equation. So Depress equation, which is the equation given was degree 3, and Depress equation means it reduced 1 degree, that become degree 2. Now starting from this, the last term is remainder. So starting from this constant x and x square. So we write from this side x square plus 3x plus 2, and remainder is equal to 0. So we get the Depress equation is quadratic equation. So if we solve this quadratic equation, we will get another 2 roots, which are the required. Find the other roots. So for other roots, to find the other root, q of x, that is equal to 0. Become equation. Now solving by factorization, we get 2 factor x plus 1, x plus 2 equal to 0. Or x plus 1 is equal to 0, we get x is equal to minus 1. And second factor x plus 2 is equal to 0 mean x is equal to minus 2. Hence the other roots are minus 1 and minus 2. Now the last question 6. The same method if minus 1 and 2 are roots of the quadratic equation, of the quartic equation, equation of degree 4. Quartic means equation of degree 4. Use synthetic division to find the other root. So first step, roots are given, minus 1 and 2 are the roots. We will divide this by minus 1 and 2. Write down the equation. It is already in standard form and there is no missing term. So write down the coefficients. Quotient of x4, 1, minus 5, 3, 7 and minus 2. Dividing it by first root, minus 1. So drop down the first coefficient 1, multiplied by minus 1. 1 into minus 1 become minus 1, adding to the next quotient. Minus 5 minus 1 minus 6, multiply by minus 1 become 6, adding to the next become 3. 9 into minus 1 become minus 9, adding to the next become minus 2. Minus 2 into minus 1 become plus 2, adding to the next. The last term remainder equal to 0. Again divide by 2. So drop down the first coefficient 1, multiply by 2, 2 1 the 2, adding to the next quotient we get minus 4, minus 4 into 2 minus 8, 8 to 9 that become plus 1, 1 into 2 become plus 2, and minus 2 plus 2 adding 0. The last term is remainder. So we get again remainder 0 because 2 is a root. Minus 1 and 2 are the roots. So there we get their remainder equal to 0. So the last equation, decrease equation, we get that is q of x become x square minus 4x plus 1. To find the other root, q of x is equal to 0, mean this equation x square minus 4x plus 1 equal to 0. So by quadratic formula, we solve this by quadratic formula. Compare it with the standard form of quadratic formula, we get a is equal to 1, b minus 4 and c is equal to 1. Putting the values in the quadratic formula, value of a, b, c, we get this form x is equal to, by simplifying, minus minus 4 become plus 4 plus minus square root of minus 4 square 16 and minus 4 divided by 2, or simplifying it 4 plus minus 16 minus 4 square root of 12 divided by 2. Now we write 12 under root is 4 multiplied by 3 square root, or 4 square root is 2, we can write 2 under root 3. Now 2 is common in the numerator. By taking r we can write 4 by 2 plus minus 2 under root 3 by 2. So here 2 to cancel, we get 2 plus minus 2 to cancel under root 3. So we get two other roots, 2 plus under root 3 and 2 minus under root 3, which are the required roots. To find the other roots, so the required next two roots are 2 plus under root 3, 2 minus under root 3. So that is the end of our today lesson. Thank you so much. Allah Hafiz.